So just to back up a little bit, we spoke about breaking down compounds in our last lesson, all right? And we said that if you look at point number 3, the atoms of elements in a compound are held together by forces known as chemical bonds. Okay. Next point. Compounds can be broken down into the elements they are made of, and we break down a compound by breaking its chemical bonds. The reaction where a compound is broken down into its elements is called a decomposition reaction. All right, so let me explain this to you in better terms. Just say I take water, right? This is one molecule of water. And if you remember what we said about molecules, molecules are made out of 2 or more different types of atoms bonded together, right? And if we have like many water molecules in the same place, then we get enough water to drink, right? And that's the compound of water. So the compound of water is the actual substance. The compound of carbon dioxide is the air we exhale. All right. Now, if I want to take water and I want to break it up into its elements, and tell me in the chat, what are the elements of water? When I break up water, what elements do I break it up into? Guys, I'm waiting for your response on the chat. Okay, so I have water. Yes, Quentin said hydrogen and oxygen. Excellent. So if I take hydrogen and oxygen and I bond them together, I'm going to get water. But if I want to break down water, I break it down into hydrogen and oxygen atoms. Okay, if you see here, I actually made a little bit of a mistake. When I break down water, it becomes 2 oxygen atoms and 2 hydrogen atoms bonded together. So can anyone tell me why is this hydrogen, why is it that there are 2 atoms bonded together? Why is it not a loner, just one atom on its own? What do we call it when 2 of the same atoms are bonded together in nature? What kind of molecules are those? Let's see if you guys remember from the previous activity we done. I am just adding one more. There we go. Does anyone remember? It starts with a D. Okay, so I'm going to tell it to you. It's called diatomic molecules, right? So if I want to go from hydrogen and oxygen to water, then I just need to reverse my reaction. So the arrow will be facing the other way. Okay, and the bonds that are keeping hydrogen connected to oxygen and the other way around are called chemical bonds, right? And we can't just break chemical bonds physically by sorting them out with our hands or filtering them like we filter, sand and water, okay? Because there are very strong bonds connecting the two. Okay, that's where we come to something called a decomposition reaction. So guys, if I want to break down compounds that are very strongly bonded, like salt. Salt is made out of sodium and chlorine, okay? And those are both elements on the periodic table. If I want to break them down, I need to go through a series of reactions, right? A reaction is where you take something, right, and you make something else out of it, or you take something and you break it down. A simple example is if you are baking a cake. it's a reaction because you're taking a whole lot of ingredients and you're putting it together and they are bonding with one another, and in the end you get a totally different thing. You get a cake, right? So if it's your first time, you don't know how to bake a cake, then you're not going to know that there's an egg in the cake, there's flour in the cake, because the cake tastes differently than just an egg on its own or flour on its own, right? The same thing with compounds and elements. Okay, so we're reading on this slide here. Compounds can be broken down into elements. Guys, please mute yourself. I don't know who's not muted here. To break a compound up, we need to break the chemical bonds that hold the atom together. And how do we do this? There are two ways we can do this. The first way is that we supply heat or electrical energy to break the atoms up. And this is called a decomposition reaction. Decomposition means when you break up something, right? So when we die, then our bodies are broken up by bacteria, right? In the same way, when we want to break down a compound, we call it decomposition. When we use electricity to break down compounds, we call it electrolysis, all right? So the reaction, the process is called a decomposition reaction, but when we use electricity to break down a compound, we call it electrolysis. Okay, let's talk a little bit about the process of electrolysis. So today we're going to look at the decomposition of copper chloride, right? So we're taking copper chloride, which is a compound, and tell me in the comments or the chat, what two elements is the compound copper chloride made up of? And you can look on the screen for answers. What are the two elements that copper chloride is made up of? Half of the answer is in the name. And I want all of you to attempt to answer. Tendo says, yeah, Tendo, your answer is right. But I want everyone to try and answer as well. So chloride is just, we use the word chloride when we want to end the name of a compound, but there's no chloride in the periodic table. Okay, so the answer is, it's made of copper and chlorine, right? Just as Tendo said. And Tendo, you can message everyone. I see that your messaging is private. Okay, so the chemical formula for copper chloride is CuCl, right? So guys, we know from the periodic table we have symbols. Okay, so the symbol for copper is Cu. We don't write it in full, we write it in short. The symbol for chlorine, and chlorine, remember, it's a gas, all right, and it's very dangerous. If it comes into contact with your body, you can burn. It's also the stuff you put in your pools. When electricity passes through the copper chloride solution, a substance dissolved in water. So a solution is basically a substance dissolved in water. So if you take, and a substance could be a salt, right? If you take, for example, salt and you put it in water and you stir it, it becomes a solution. Okay, so copper chloride is like a crystal. It's a blue crystal. And when we drop copper chloride into water and we stir it, it becomes a blue solution. And it's called a solution because when you take a salt like copper chloride and you put it in water, it dissolves, right, and becomes a solution. The energy decomposes the compound copper chloride into the elements copper and chlorine. So let me show you what I'm talking about. If we were in school, we'd be able to do this experiment. So basically what we're doing here is that we're taking copper chloride, right? They're basically crystals. And we're dropping it into a beaker. We're looking at picture 1 here. And we are stirring the substance until it dissolves completely. And then we're connecting through an electric circuit, right? We're connecting a positive and negative terminal to those wires. One side we're connecting a nail or a, what do you call that? A money clip. And on the other side, we are connecting, just take it as a metal, right? We're putting two metals and connecting it to these little crocodile clips. And as soon as we attach the battery, we know that electricity is running through those lines. When electricity runs through those lines, remember, we break down compounds when we pass electricity through the compound. So electricity is passing through the copper chloride solution in this beaker here. Remember, a beaker is a jar, right? And when electricity is passing through the copper chloride solution, it's breaking copper chloride into copper and chlorine. Okay, guys, if I am moving too fast, please let me know. Tell me in the chat if you are with me so far. This section can get a little bit confusing, but this is the worst that it gets, basically. Doesn't get worse than this. Okay, Tendo is with me. Chloe, good. All right. Okay, I'm still waiting for the rest of you to respond. So guys, we know, how do we know that copper chloride is being broken down? Thank you, Ethan and Marcus. We know that because if we look in the experiment here, right? If we look very closely, and I'm looking at the picture on the right here, we see that on the left side, on the left metal, there's bubbles that are forming, okay? And on the right-hand side, you can't really see that, but there's supposed to be a reddish or like brownish substance that forms, right? So the brown substance that forms is the copper, and the bubbles that are formed is the chlorine gas. Did you guys know that chlorine isn't a liquid in its nature? It's actually bubbles or a gas, all right? We convert it through a series of chemical reactions into a liquid. Okay, cool. So that is that. If we look at it in another picture, we see that we have one metal over here and another metal, and they both are being connected with wires, all right? One side is connected to the negative terminal of the battery, and the other side is connected to the positive terminal of the battery, right? Where as soon as we connect the wires to the battery, electricity can run through. And the awesome thing about water, water is a carrier of electricity. And I don't know if you guys remember from when we went to Saibono, and I think there was an experiment that had to do with water, or when we held hands and the electricity passed through all of us, and then the light bulb started lighting up. So water works the same way. We can't really see it, but water is like the liquid wire. Okay, so electricity will pass through from the negative all the way in the wire, out through this metal, then going through this metal, and all the way back to the positive terminal. If we look on this metal here, we see that there's little bubbles, and those bubbles are chlorine gas. If we look at the right-hand side, the metal is becoming like bronze or gold, and that is a sign of copper, okay? And yeah, and then the blue solution is copper chloride solution. Someone said something. Conductors, yes, conductors. Another word for the metals are conductors. And guys, does anyone know what a conductor is? In this diagram that I'm showing you here, what are the conductors? There are like 3 conductors of electricity. I'm writing the definition of conductors in the chat here, so you guys can just refer to that. So I've written here, conductors allow electricity and heat to pass through them. Yes, Nintendo says the wire is a conductor, the water is a conductor, and the metal rods are a conductor. Excellent, Nintendo. Very nice. And I hope the rest of you are understanding what a conductor is. We are conductors also because we have like 80% of water within our bodies, all right, and we know that water is a conductor of electricity. For example, you are in the bath, all right, and I know people always warn us that don't let anything electrical be dropped into the bath accidentally, or don't let it be anywhere near you when you're swimming, etc. Because if that electrical appliance drops into the water, then you can get shocked because electricity travels in water. Okay. Yeah, I think that is basically the lesson we have for today. And we know that the last point over here, the blue copper chloride solution becomes lighter as the copper chloride breaks down. So as this process happens on and on, if we keep this electric circuit going on for days, after some time it's going to be clear. There's not going to be any blue pigment in the water, right? Because we know that the copper chloride is broken up into copper on one side and chlorine gas on the other side. And guys, this is what we have to go through to break down a compound. That's how strong bonds a compound has. We can't just break it down through normal means, right? But if we had something like, let's say salt and water, and we wanted to separate the salt from the water, then we know we'll just boil it. All right, and we'll allow it to evaporate, and that's how we'll separate the salt from the water. There's a process called desalination, and that's how people take seawater and they separate the salt from the water, and that's basically how we get salt and clean water. Okay, we're not going to have an activity for this lesson, but you guys are going to be writing a test for me in about, I think it's next week sometime, right? Or maybe the following week, Monday. It's not going to be like a test. Obviously, we can't write a test during this time, but it's going to be more of an assignment, right? And you're going to have a deadline for it, okay? And whatever we learned up till now and even tomorrow, you're going to be tested on that. All right, so I'm not going to go very much deep into this topic because it is a bit confusing and can be complicated, but I think you guys should understand up till this point. Okay, so I'm going to share with you the PDF on